Hi guys, I hope you're doing well. So today we're gonna do electrical circuits for grade 10. Then for grade 11 and 12 you can watch this video for in revision, right? So let's quickly look at what you call the voltages. So I normally call them 3Vs because their SI units are volts, same. Actually these things are the same thing, but the only difference is going to be where it is connected, and then that's the current flow through the circuit. That's the only part. Then when you look at the potential difference, we are saying that it is the energy transferred per unit electrical charge flowing through it. So it means that the energy transferred, it will be W, and we know that you measure it in watts, and then your charges, it will be in coulomb. So it means that we're talking about the voltage. Let me see the voltage that is going to be measured around a what? A resistor. That is a potential difference. Then when you look at terminal potential difference, you are talking about the potential measured across the terminals of the battery when the charges are flowing in the circuit. For example, let's say I have, this one is representing a cell. When I have a longer line and a smaller line, this is a cell, but if I put another cell, I am forming a battery. And also remember that a longer line there, it will be your positive, and your shorter line, it will be your negative, right? And let's say I have a battery. Now I have a switch here. Okay, let me make it. I have a switch and also a resistor there, example. So you can see this switch is what? It is closed. But now we're gonna read the voltmeter here that is sitting here, right? It means that we are reading the terminal potential difference when the switch is closed. Okay, then when you go to EMF, you are seeing that the EMF, it is the maximum energy provided by the battery per unit charge passing through it. It is the maximum energy provided by a battery per unit charge passing through it. This definition normally you're going to like it when you go from grade 11 to grade 12. So the EMF basically going to read, oops, I didn't create a space. Okay, let's say the switch is open. Now we're gonna read the EMF, right? You're gonna read the EMF. You're gonna read the EMF because there's no charge flowing through the circuit. Then you could watch the EMF. Right, so once you go from grade 11 to grade 12, now we're gonna talk about the internal resistance in a circuit. So meaning that, remember, the EMF, we are saying that this battery has this minimum energy they can provide, right? For example, let's say because we have a cell, you know that one cell, let's say one cell contain 1.5 volts, and then another cell will contain also 1.5 volts. Right, so it means that it is the maximum energy that the battery will going to provide to the circuit. But immediately when you close the switch, now we no longer have EMF. We have a terminal potential difference, meaning that your EMF is going to drop a bit, right? You're going to drop a bit. But that one you're going to learn it when you do grade 11 and 12. For now, just focus on EMF. You're going to take your EMF as the same as terminal potential difference. But once you go from 11 and 12, EMF is EMF. Potential difference is a potential difference, right? Meaning that is a voltage that is internal voltage. Right, and then let's look at the current. So we are saying that a current strength, it is the rate of flow of charge. Remember, let's say a wire has this thing. So we're going to talk about how does the rate of flow of charges that passes through that wire, right? So we have the Q, the Q is the charges, and then our time must always in second, and our SI unit for current, it will be amperes. Hey, you understood. Then then also the 1 coulomb is defined as the charge transferred in a conductor within a 1 second if the current is 1 amps, right? This is how we calculate the current. There's nothing much also in that current. This is how we calculate the current. And also remember, as in the voltage, we have said that the voltage is equals to W over Q. So now you must be very careful when you are doing the question when they ask you calculate the charge. Now we're gonna look at this calculate the charge, meaning that you can get the charge from formula your current as well as the formula yeah, a voltage. So you want to look at that and see that are we given energy transferred. If you are given the energy transferred, you can normally get the charge. And then I think I made a mistake. The energy transfer, it will be watts. I mean joules. Not state. It going to be joules, not watts. So watts is when we are dealing with what? With power. Right. So now we in the energy transferred, it will be joules. And you know the charge is what? Is Q. I mean the charge is what? Yeah, the charge is Q, but the SI unit it will be what? Coulomb. Right. You must be careful of that. And then now we have the direction of your current. So your direction of the current, it will be determined by, okay, how does the current flow through the circuit? Now remember, we have the longer line here, it will represent the positive sign, and the shorter one, it will be what? The negative. So we have the longer positive, the shorter the negative, the longer positive, the shorter the negative. So meaning that our current will flow through positive side going to the negative side. So your current will flow here, and this A1 we call it an armature. Then this one it's flow, and here we know grade 10, grade 11 and 12, they know what's happening here. And then this is a switch, as you can see there, and then this go back here, the current, right? So rather the current will flow from what? From positive to negative terminals of a what? Let me say a cell or a battery, because sometimes it can give you what? A cell. That is the direction of conventional current. It's flow like that, from positive to negative. Right. Now let's look at how do we measure the potential difference as well as the current. So remember, we have what you call the armature and the voltmeter. So rather the armature is the instrument that measures a current, right? It's measured a current, and also this thing is connected in series, right? So we have what you call series connection and parallel connection, right? I will tell you what is the difference between series and parallel connection when you are connecting the resistors, all right? So this one is connected in series is because it has what? A low resistance, and then the voltmeter is going to measure what? The voltage. And then this one is connected in what? In parallel, and also it has a high resistance, right? For an example, when you connect the current, when you connect the armature, so basically let's say we have a battery. Now we're gonna connect your armature. We're gonna represent as like a circle, and then you see A, mean that this is what? The armature. Then let's see, here I have a switch, then here I have what? A resistor. This is how we connect the armature in what? Series connection. And then in parallel connection is when we have different branches, right? So we have, let's see, parallel connection is when we have different branches, rather is when your resistors are connected differently, right? So basically, now to measure the voltage across the resistors, normally gonna put your voltmeter here to measure that voltmeter, right? And also here you can normally put your voltmeter here to read this voltage across this resistor. But in parallel, you connect it like this, and then connect it like that. Okay. And then we have what you call a resistance. Basically, the resistance basically is the opposite of what? Of the flow of electrical charges. Basically, going to oppose the current, right? So meaning that now, it means that the relation between the current and resistance are not directly proportional. They are what? Inversely proportional. And normally current will go where there is less resistance. Okay, and then this is how we calculate our resistance. We could R is equals to voltage divided by the current. So now this resistance now goes along with what you call the Ohm's law, right? And we're saying that the Ohm's law is saying that the potential difference across a conductor, it is directly proportional to the current in the conductor at constant temperature. Meaning that the relationship between the current and the potential difference, firstly, the relationship between the current and the voltage are indirectly proportional, meaning that if I increase the current in the circuit, I will also increase the voltage in the circuit. But if I increase a current in a circuit, it then means that I want to decrease the resistance, meaning that the relationship between the resistance and the current and the voltage are inversely proportional. Again, meaning that if I increase the resistance of a circuit, I am decreasing the current of the circuit, as well as the what? The voltage of a circuit. Now, when you look at this triangle, you can see that I have voltage, then I have this star or T, then under that I have what? Current, and I have what? Resistance, and I have what? Voltage, right? So this line here, I wonder this one, and then it will mean that it will mean division, okay? And then this line here that's facing downwards, the vertical line, it means that you're going to multiply. For example, if you put your thumb here covering the voltage, you can see that, meaning that if you're looking for the voltage, you're going to say voltage is going to be equals to I, because I say this line is going to represent multiplication. So you're going to say I times R, right? Then if you're looking for the current, you can just place your thumb in current covering the current, meaning that you're going to focus on, let's say, current, meaning that you can see that the voltage is divided by the current. I mean that to calculate the current, you will say the voltage divided by the resistance. Now, if you're looking for the resistance, basically you're going to take your thumb and cover the R. When you cover the R, you can see that I have voltage divided by the current, meaning that in order to get the resistance, I will have to say voltage divided by the current, which is how you calculate the current. And this is our SI units, ohms. Hence we say Ohm's law. Wow. Now let's talk about how do we connect, or the connectivity of the circuits, rather of the resistors in the circuit. Now we have what you call a series connection and parallel connection. So series connection is just one straight, one path, right? And then parallel connection, different path, different straight. Now for in parallel, you can see parallel I go straight sabo thabo, I'm going to this straight sabo ke starter sabo mashopa. Do you understand that part? But here in series I have a starter one fellow, only starter one fellow. See, it's a straight. That is meaning that your current will go straight. Right. For example, let's connect our resistors in series. So we're going to make only two resistors. So here I have resistor. I'm going to name it R1, and then this one I will name R2. Okay, so this one are in the same street, right? House number 1, let's say house number 1 and house number 2. So the current that is going to flow in resistor 1 is the same as going to flow at resistor 2. Hence I say that the current is going to be the same throughout each resistor, meaning that the current in house number 1, it will be the same as current at house number 2. Why? Because they are on the same street, or rather they are connected in the same street. Hence we see the I1, remember that the I represent the current. So the I1 is equals to the I2, and I2 meaning that you are talking about the resistor number 2, right? So in a series the current is the same. But when you talk about the voltage now, the voltage in series connection is going to divide itself. Meaning that let's say the total voltage that may come from the battery is going to divide itself. Meaning that that total voltage is going to divide itself according to how does the resistor has, or rather how does the resistor have amount of ohms, right? Meaning that let's say R1 we have 3 ohms and then R2 we have 4 ohms. Okay, now it means that let's say our total voltage it will be 8, right? And then I'll say let's divide it into 3. So I want to say, let's say I have 5 voltage and 3 voltage. So this is a division that the voltage that you're gonna divide itself. But you will just calculate the voltage. I just make an example here. Right, so it means that if the voltage is going to divide itself, those total voltage, let's say, going to divide into 5, as well as going to divide into 3, because we have 2 resistors that are connected in series, right? So, as I said in red here, more voltage will go to less resistance, meaning that which one is more? 5, meaning that more volts, which is 5 volts, will go to less resistance, meaning that my 5 volts are going to be rated here, 5 volts, and 3 going to rate it here because it has high resistance, meaning that a lower voltage will go to a higher resistance. It's like a vice versa of what I have said here, right? It's Ohm's law, not me. And to calculate the resistance, basically gonna add your resistance together because you're in series, right? So you're gonna say the R1 is 2, while to calculate the RS, you're gonna say 2 plus 4, and then you get what? 6 ohms. This is your total resistance in series. Now let's connect our resistors, the same resistors, let's connect them into parallel connection. So parallel connection, we say that you're going to have different streets, right? So let's say this one, the R1 is connected there as well as the R2 is connected there, right? And then this from that source, right? Now in parallel connection, we say that the current now going to divide itself, meaning that same as the voltage, like vice versa of the voltage, but in parallel connection we have what? Current. So the current, it will divide itself. Let's say if we have the total voltage, the total current going to divide itself, right? So remember, let's say R1 we still have 2 ohms, and then R2 we have 4 ohms. Okay, so we're gonna say that the current is going to divide itself. Let's say again we have let's say we have the total current. Let's say for example a total current of 8, and then let's make an example. Another example. Let's say we're gonna have what? 5 and 3 as well, right? So this is current, 3 current and 5 current is going to divide itself, right? So now in the current, in a parallel connection, more current will go to a branch that has a less resistance, When you look here, let's say, for example, the current will go here because let's say the current will flow like this. And then when it enters here, you can see that you have T section here, meaning that another current will go up, another current will go down. It means that the current will be what going to divide itself. So when it divides itself, you're going to divide itself according to how does the branch, how does the resistance of the branch is. For example, let's say branch, this one, let's name it A, and then this one is name it B. But you can see that branch A, it has less resistance. So let's say it has less resistance, right? And then bulb B has high resistance. Okay, meaning that now those current, let's say we're gonna choose here. So let's say now between 5 amps and 3 amps, which one will go to A and B? Okay, then now I say that more current will go to what? Less branch, which is A. So meaning that my 5 amps will go to A because there's less resistance. And remember that I said resistance is what it opposes the current. Okay, and then when we look at branch B, you can see that we have what? High resistance, meaning that 3 amps will go to that. So why am saying E is supposed to be amps? 3 amps will go to branch B because it has what? Less resistance. And then remember about the voltage. I told you that to connect the voltage across the parallel connection, normally you're going to connect it like that. And this is going to lead the voltage, meaning that the voltage in parallel, the voltage in parallel connection is the same, meaning that the voltage is going to be the same as at branch B as well as branch A. So the potential difference is the same throughout each branch. So the V total can be same as what? V1 and V2. And remember, you grade 11 and 12, remember that if you are dealing with internal resistance, it's like a slightly different story. It means that your V total here is going to be the V of the external circuit. We explain it that way, don't worry. Grade 11 and 12. Okay, let's focus on how do we get the resistance. Now, to get the resistance of parallel connection, normally let's say you're going to say 1 over Rp, that is close to 1 over 2 plus 1 over 3. Then you're going to say 1 over 2 plus 1 over, 4. Then how much are you getting? You want a fraction rather, which is 1 over Rp, that is equals to 3 over 4. Then the next step what you need to do is that you're gonna take your Rp, you're gonna put it like that. You're gonna swap the values. So basically this 4 will go to upstairs, and then 3 will go what? Downstairs. And then remember that if you take Rp, you're gonna have Rp up and then 1 down, which is same as Rp. Then the Rp will be same as what? It will be equals to what? 4 over 3. What? Ohms. Now, if we have 2 resistors connected in parallel, so basically you can say, Rp, it will be equals to the product of your resistors, meaning that you're going to times them as 2 times 4, and then divided by 2 plus 4. Then when you say 2 times 4, you are getting 8. Then when you say 2 plus 4, you are getting 6. And then 8 divided by 6, you're getting how much? Can I write it here? You are getting 4 over 3 ohms. And as you can see that we found 4 over 3 and then 4 over 3 ohms. So this is how we calculate the resistance in parallel. And then this one is how we calculate the resistance in series.